Right, so today we will talk not so much about R coding, but instead about dynamic documents and how to present your results or your report in a nice way. And we will also talk about how to manage large projects in R. Specifically, we will talk about R Markdown documents, our studio projects, and finally, version control with remote repositories. You will learn how to create your own dynamic documents in R Markdown, how to start and manage a large project using our studio projects, and finally, how to contribute to an online repository on GitHub. Let's start with our Markdown documents. So far, you have been using our scripts to write your code, and if you have generated a text document, most likely you have saved the figures and the tables externally and then included them into your Word document or your LaTeX document. Luckily, the knitr package allows us to do all of this in one place. It allows us to combine in a single script the R code, the text, and also LaTeX math notation, and then use this script to generate a PDF, an HTML website, a Word document, or even a Beamer presentation. And the lecture slides that you're seeing here, and also all the assignments, were all generated using R Markdown. So to use R Markdown, you have to install the knitr package. And if you haven't installed LaTeX so far, you need to have LaTeX installed for knitr. And this is also a good place to start using LaTeX, because Markdown allows you to generate LaTeX document without the steep learning curve of writing LaTeX code. So you install packages knitr, and then you just initialize the library by calling the library, so as usual. Then R Markdown allows you to write either LaTeX code directly, or it allows you to write a Markdown language. And the Markdown language is a simplified language that generates the markup language for you directly. So instead of having to type out all the LaTeX command, you can use this more simplified language that will then generate the LaTeX command for you. And we will focus on R Markdown here because this is what actually makes this so easy to use. So if you want to start a new R Markdown document, you go to File, you open a new file, and you select R Markdown from the drop-down menu. And what will pop up is this window here, where you write down the title, the author, and then you select the type of document that you would like to generate. And you can also change the type of document later. Inside the script, you can now write normal text. You can write LaTeX code, or you can write R code. And if you want to write R code, you should embed it in a so-called R chunk, code chunk. And a code chunk is started by writing 3 backticks, opening curly brackets, and inside you type the programming language that you would like to have included, and then you close the chunk by writing the 3 backticks again. And inside this chunk, you can write whatever R code you want. And this example would look like, in the document, this will look like here, this black window, where you can see the R code that is written, and then the output will be displayed underneath the code window. So let's look at an example real quick. So here we have just an empty console, and then we start a new file, and we choose our Markdown. We'll call this file test, and we would like to have a PDF. And it will automatically fill it with some chunk code that we don't want. And now we can use this as a normal script. So here we can type some text. So here is text. You can write a title. You can use a subtitle, and we'll talk about how to format the text and writing these like sections and subtitles in a minute. And then afterwards, we would like to include some code, and then we include a code chunk, which we can choose from here. R code, and now we can just type whatever code we want. Let's say y is equal to 6, and we can execute this as usual. Command enter. Now you can see here on the right side y has been evaluated as you know this from just normal R scripts. So literally the only difference is that when you're writing code, you have to embed them in these R chunks, and outside you can just write normal text. You can also write inline code. This is, instead of having a separate code chunk, you can just embed the R code directly inside your text, and you do this by writing just a single backtick followed by the programming language. Here this is going to be R followed by your R code. And this, for example, useful if you have all your code chunks, but then in the end you want to write a nice conclusion about your result, and you want to include the numeric value of the conclusion of the results directly in your text. And you would also like to update this every time that you're reevaluating your calculations, for example, and then you could just include in here the variable that contains the result, instead of manually retyping the numeric value of the result in your text every time. So once you have written your code and all your text and everything is formatted, you're going to knit the document. And you do this by typing this button knit. And what this does, it just evaluates all your R code, and it takes all the markdown text that you wrote and generates a single PDF from that. And to look at an example how this looks like, we can see, for example, here you go. We can see here the solutions that I wrote for assignment 2. And here you can see normal text, which is generated using LaTeX. And then here is this code chunk where I'm loading the libraries, for example. And then the next code chunk here, I'm taking a glimpse at the data, and the output will be displayed just underneath this code chunk. If you're writing outside of the code chunks, you also like to format your text in a nice way. And this is where the Markdown language comes into play. So if you want to type a header, that's what I just showed you before, you write a single hash symbol followed by the name of the header. This is equivalent to creating a new section in LaTeX. If you type two hash symbols, this will be a subsection, 3 will be a subsection, and so on. If you would like to have your text in bold, you wrap it by double asterisk. If you would like to have it in italics, you wrap it by a single asterisk. You can also just include normal LaTeX if you don't know how to write it in RMarkdown, or you would like to have the functionalities of your LaTeX command. You can just type the LaTeX command directly. If you want to have a list or a bullet point, you can just type each item after a dash or after a plus symbol, and the plus symbol would just create an indented bullet list. If you want to have an ordered list, you just start them by typing, for example, first. The only thing to keep in mind here is that you just type the same number over and over again. This tells R that all of these items belong to the same list, and it automatically generates numbering for you. So, for example, if you want to have an alphabetical list, you just type A, and it will automatically know that it starts with A, and then B, and then C. Your code chunks, oftentimes you would not want to have for example, your code shown, but only your results, for example, when you're writing a report. And then there's a lot of options available in your code chunk that you can specify by in the backticks, after the R, where you specify your programming language, you type a comma, and then you can specify all of these arguments. For example, if you type echo equals false, this does not show the R code, but it will show the output. And in all the assignments that I uploaded, the solutions were already in there. I just decided not to show you the code, so echo was false, and also results were hidden so that you cannot see either the code nor the results. If you type include equals false, it does not show you anything. It does not show you the R code or the output in the document. If you type eval equals false, it does not evaluate the chunk at all. And this might be useful, for example, if you want to show a code example that is wrong, as for like an educational purpose. But of course, you don't want R to evaluate it because it cannot evaluate code that is wrongly written. With results equal hide, it will run the code, but it will not show you the results. And warnings equal false or message equal false will not print any of the warning messages. And this might be useful when you're loading libraries. Oftentimes these libraries generate warnings, for example, if your library is outdated or so. And this is also something that you do not want to have in your final report most of the time. You can also, there's a lot of different output options. You can, for example, change the theme. So, for example, this LaTeX, this Beamer presentation has a certain theme, and there's a lot of other color themes available. You can specify how data frames should be printed, how code should be highlighted, or whether or not, for example, there should be a table of contents. If you want to have a table of contents, you type TOC yes. Alternative options for how to print tables or data frames are cable or tibble. The highlight option, yes, as I said, allows you to specify how the code chunks should be highlighted. So working directories work a little bit differently in RMarkdown, because RMarkdown will automatically, when it generates the document, it will automatically take the place where this markdown file is saved as the working directory. And this means anything that you're writing in the code chunks that refers to any folders, for example, when you're saving output or loading data, can be written in a so-called relative file path. And the relative file path, it says you're just writing where to go from the current position. And the current position can also be in a different folder. So probably so far you have always written a so-called absolute file path, where you just say from your user folder, go all the way to a certain folder. Whereas a relative file path just says period, means this folder that we're currently in, and then go to the data folder, which is a subfolder of the root folder, and read a certain data set from there. And this might be useful if you're referring to several different subfolders within the same document. For example, if you're reading data from the data folder, you're saving output into the output folder, and you're saving figure into a figure folder also. Our notebooks are kind of similar. You can also combine text and output. The only difference is that you can preview the document without having to knit it over and over again. And this is very similar to Jupyter notebooks. If you have been using, for example, Python before, you might have used a Jupyter notebook to combine text and Python code and Python output in one document.